Hi everyone, welcome back to Math 111Z. We are going to do section 4.3. Section 4.3 is about logarithmic functions. So, I'm sure a lot of you have fear in your heart when you hear the word logarithm, but as long as you understand what logarithms really mean, they're not that scary. Okay, so logarithmic functions. The function f of x equals log to the base b of x is the logarithmic function to the base b. Okay, the log function, the reason why log functions exist is we had to figure out a way to describe the inverse to an exponential. So the log function is the inverse to the exponential function. So here's the way it works. For example, log base 2 of 8 equals 3. Since 2 to the third equals 8. So let's try to figure out what the heck log base 2 of 8 is really asking for. So it asks, what do you raise the base to? The base in this case is 2. So what do you raise 2 to get 8? And nowhere else you're going to see 2, 2, 2 back to back to back in a sentence except for math. So what do you raise 2 to get 8? Well, you raise 2 to the third power. So the answer to a log question is, what is the exponent necessary to put on the base to get to the number we're logging? Okay, for example, if I ask you to do log base 5 of 25, you're like, well, 5 times 5 is 25. So the mistake a lot of students make is they're like, well, this equals 5. But it really doesn't equal 5. Let's see what it really equals. So to do this problem, I like to set this equal to some variable x. Then I log roll it. 5 to the x equals 25. You're like, log roll? What do you mean? The log roll. Okay, so you take the base, you roll it to the other side, so 5 to the x equals 25. Call that the log roll, okay? Then you know that 25 is a power of 5. 25 is 5 to the second. So I have 5 to the x equals 5 to the second, meaning that x equals 2. So we can say then that the log base 5 of 25 equals 2. All right, let's go over another one. What if I give you this one? Log base 3 of 1/27. That one's tricky. You're like, oh, I got a fraction. So I'm going to set it equal to x, and I'm going to roll it. 3 to the x equals 1/27. Hopefully you recognize 27 is a factor of 3, or it's a power of 3, excuse me. 27 is 3 to the third. 3 times 3 is 9, times 3 is 27. And then this is the same as, remember, a negative exponent. So 3 to the x equals negative 3. Therefore, x equals negative 3. So log base 3 of 1/27 equals negative 3. Alrighty. You're going to see some in assignment where you have to go back and forth between exponential and logarithmic form. So if I ask you to rewrite log base a of b equals c in exponential form, all you would do for that is you would log roll it. Okay, a to the c equals b. There you have it. So we went from logarithmic form to exponential form. There'll be a couple of these on the assignment. So what if I had to go the other way? Rewrite x to the y equals c in logarithmic form. So I know the base is x, so I got x there. And remember, when I roll it, the y has to be on the other side to get x to the y, so then c is that number right there. Hey, you could check it. Check with the log roll. Okay, x to the y equals c. Yep, good to go. All right, let's talk about some common buttons on the calculator. You don't really use a calculator, so to speak, like a TI or anything, but there are two bases common to the calculator, and these will work in Desmos too. If you have f of x equals log of x, you're like, hold the phone, dude, I don't see a base on that. You're right, there is no base on it. It's kind of like a square root. You don't see a 2 in there in the little elbow of the radical sign, right? Same thing here. Log of x is the common log. It's understood to have a base of 10. Okay, so if I ask you to do log of 10,000, that is like log base 10 of 10,000. So what do you raise 10 to get 10,000? Well, 4. All right, just for kicks here, let's look at it on Desmos. If I had to do log of 10,000, it gives it to you right there, okay? So Desmos is able to just figure out that log is log base 10, just like a calculator. Let's talk about the other common base. The other common base is base e. Okay, e is a very common number. It's like pi in that it's a constant that doesn't repeat and doesn't terminate. Okay, so f of x equals ln of x is the natural log. Its base is e. Okay, e is approximately equal to 2.71828. So it's a constant like pi. All right, so we would definitely need a calculator on these because there really is no way to figure out what you'd raise e to get 5.36. Like, what do you raise 2.718282 to get 5.36? Impossible to do without a calculator. So I go down here, I'm going to go ln of 5.36. Then you listen to my open math and see what they want you to round to. So 1.679 if I go to 3 decimal places. Okay, 1.679. Alrighty. Let's go on. Get a new page. And we'll move on. We can use the log roll to solve simple logarithmic equations in exponential equations. Simple log equations. So like this one that we're going to do here. Log base 9 of w equals 2. All right, so you're trying to find out what you need to log in order so that 9 to the what power is going to be that number, right? Or 9 to the 2 is going to be that power. So 9 squared not power. 9 to the 2 is going to be what you're logging. 2 is going to be the power. Okay, get my words all twisted up here. So W equals 81. Simple. Log roll it, and you undo the logarithm when you log roll, and there we have it. Okay, this one right here, log base 3 of x equals -8. If you see something like this come across your desk when you're doing the homework, 3 to the -8, that's like 1 over 3 to the +8. 3 to the +8 is a giant number, so I would just put this into my open math. Leave the answer like this in my open math. Okay? My open math, we're going to abbreviate as mom. Okay? Here we go. We have a bunch of properties to go over today and in your next lesson, but these are the inverse properties of logs and exponentials. So since the log and exponential functions are inverses of one another, what one does to x, the other undoes, okay? So, but let's write those down specifically. So we have these properties. So log base b of b to the x. So I'm log base b'ing the base b raised to a power. What do you have to raise that b to get b to the x? Well, you got to raise that b to the x to get b to the x. And then the opposite way, if I have b to the log base b of x, same thing, the b and the log base e cancel. All right, and then just to look at it with the special cases of the common log and the natural log, we'll write those special cases down. So log of 10 to the x equals x, 10 to the log x equals x, and then the ln of e to the x equals x, e to the ln of x equals x. So they're going to try to trick you on my open math. They're going to give you a bunch of those. Alrighty. Here we go. We are going to do some Desmos work and calculate some other logarithms. So let's look at something like log of 885 on Desmos. We'll look at ln of 45 on Desmos. And then we're going to look at log base 5 of 45 and see what we need to do. The first two are easy because that's all you got to do is put log and ln in. So here we go. I got log of 885. There's that one. And then I'm going to do ln of 45, and I get that. Now I'm going to assume there's no subscript on the logarithms. So I'm going to do log of 45 divided by log of 5 for the last one. And I'm going to write that down. And just to show you the property we just used, it's called the change of base formula. All right. So basically there's Desmos for those three. So log of 885 is going to be 2.947. ln of 45 is 3.807. And log base 5 of 45, we would write that as log of 45 over log of 5. So on Desmos, you see that you got 2.365. So this last thing in general, this thing called the change of base formula, if you have log base A of B, we're just going to do log of B divided by log of A. So we change the base to base 10. All right. You could also do ln of B over ln of A. All right. Just in case that comes up. Okie dokie, moving on. let's do a quick property before we do our last flourish of examples. This property here, ln of x to the n equals n times the ln of x. Alrighty, you can drop that exponent down. The reason we're doing that is to solve this kind of problem right here. So if I have solve 7 to the x equals 813. You're like, I know 7 to the first is 7, 7 squared is 49, 7 to the third is like 343, 7 to the fourth is going to be over 2,000. So it's the answer is going to be between 3 and 4, but I'm not going to want to guess and check that whole thing. So what I'm going to do, and this is a legal algebraic move, is I'm going to take the natural log of both sides. So ln of 7 to the x equals ln of 813. Then by that property I just wrote down, the x drops down. So x ln 7 equals ln of 813. Then I divide each side by the ln of 7. Put that in the calculator exactly the way it looks. And we get 3.443. So we use that inverse property there, right? The ln of 7 to the x. Well, that wasn't really an inverse property, the property I just wrote down, where you can scooch the exponent down. All right, we are going to use the inverse property on the next one. I think I was getting ahead of myself there. So this one here, e to the 10x equals 55. So I would ln both sides. And if you go up above, you see that ln of e to a number is whatever the number is. So ln of e to the 10x, the ln and the e cancel. And I got 10x equals the ln of 55. So divide each side by 10. And I got x equals 0.4007. You can check your answers, by the way, by plugging those x's in. It's going to be a little bit off because of rounding. Exponential functions are very volatile, which means small changes in x result in large changes for y. So, it's going to be a little off, but it'll be pretty close if you check. All right, here we go. Next one. Here we go. 8 to the 3x minus 2 equals 107. So we ln both sides. And then the 3x minus 2 can come down. And then you got options from here, because we could distribute the ln of 8 over the 3x minus 2. That's the tougher way. I think the easier way is to divide both sides by ln of 8 and get yourself a decimal for the right-hand side. We'll go out to 3 places, so 2.247. And then you solve it just like you did in Math 60. Algebra 1, right? You add 2 to both sides, and then you divide both sides by 3, go to the nearest 3 decimal places. I got x equals 1.416. All right. So this is going to be a going theme that you're going to ln both sides of an equation. We're going to be doing it an awful lot in the last few sections of this course. Okay, so 75 times 1.38 to the x equals 150. Divide both sides by 75 first, right? Because you don't just have b to the x, you have a times b to the x. So ln'ing both sides with that number out front is going to add an extra challenge. So we're going to divide that number first. So I get 1.38 to the x equals 2. Now we ln both sides. And then we drop the x. And then we divide both sides by ln of 1.38. So x is the ln of 2 over the ln of 1.38. Grand total, 2.152. Right, so you put 2.152 in for x, and hopefully you get pretty close to 150. Here we go. Couple more. Rewrite f of x equals 10 times 1.75 to the x in f of x equals a e to the k x form. Okay, so we just got to compare what's supposedly equal to what in here. So let me do some highlighting. That 10 is going to be your a, right? Easily enough. And then this 1.75 is going to be e to the k. All right, the x is in the same position. So here we go. What we have then is a equals 10. And I got that e to the k equals 1.75. So now I got to solve that for k. Same thing we've been doing, everyone. We're going to ln both sides. And I get that. The k comes down, or the ln and the e cancel, right? So I get k is the ln of 1.75, which is 0.560. So then my new function is going to look like this: 10 times e to the 0.560x. All right. Now let's go the opposite direction. Go the opposite direction and see if I can figure that out. So rewrite f of x equals 162 e to the 0.15x in f of x equals a times b to the x form. Alrighty. So same deal. Let's compare. So I got the 162 is my a, and then it looks like I got e to the 0.15 there equals b. So I just have to do both of those calculations. So a is 162, b is e to the 0.15, which turns out to be 1.162. So f of x equals 162 times 1.162 to the x. Alrighty, everybody. So that is section 4.3 in a nutshell. We'll see you on the other side in section 4.4.